All right, if you haven't already done so, make sure you take quiz 24. And if you haven't taken quiz 24 yet, stop the video, take quiz 24, and then resume. We are going right into our test review. All right, your test, which will be in our next lesson, will be over Chapter 7. Now, the first thing we worked on in Chapter 7 was solving trig equations like these. The cosecant of phi times the cosine of phi is equal to 2 times the cosine of phi. Or something like 6 sine squared alpha times the tangent of alpha equals 3 tangent alpha, where I wanted to find all possible answers between 0 and 360. So, at your seats, go ahead and solve these first two trig equations. Remember, if there's multiple trig functions, set it equal to 0 and factor. Forgot how to do this. Continue working on the second one, but take just a moment to check your answers on the first one. If you have any questions, go and ask them now. Otherwise, continue working on the second problem. How many say I got all 4 of those for the first one? Ooh, okay, questions. Questions. Good to go? Yes, ma'am.
Can you explain what happens after the second step?
After this step? So you got the first step, right?
Yeah.
It was getting to this point.
Right.
Right? So we see that in each term there's a cosine. So I pull out the cosine, because cosine is multiplied by cosecant. And here cosine is multiplied by -2. So I factor out the common factor of cosine. That leaves me with the cosecant, and it leaves me with the -2. Then I set each of these to 0. So obviously cosine equals 0, or 0 over 1. And then here, when we move the -2 over, it equals a +2 over 1. Questions on the second trig equation. Pause where you're at. Questions on the second trig equation. How many got all 6 answers?
I should get finished completely.
Okay, so go ahead and finish it up then. I'm sorry. I'll leave it up for a little bit longer than if you have a question you may. Again, here you're trying to think of all the possible answers because it's our idea to take those inverse functions in a sense. So we aren't limiting anything on these equations. Only if the inverse function is given to you do you have to account for the limitations.
I'm already done on that.
Okay, are you good to go? And then Jamie, you looked like you had a question. Did you figure it out? All right. We good to erase?
Mm-hmm.
Remember here, really easy. It's already got the trig function isolated. So you're just saying, when is cosine squared of 3 over 2, class? 30 degrees. And since it's understood positive, then you've got 30 degrees in quadrant 1, and then in quadrant 4 you have 330 degrees, right? But because it's a 2 theta, we've got to go around a second time, adding the 360. So when we do, what do we end up with? 390, 690, but those are all 2 theta values. Then, class, divide away the 2 to get
15, 115, 1.
Ooh, careful, not 115.
165.
195 and 345.
There we go. 15, 165, 195, 345. Questions on that? Do you remember the double angle? Now, by the way, real quick, this wasn't the problem, right? But if this had been sine theta plus cosine 2 theta, what would we have had to do if there's both a single and a double in the same equation?
Get rid of the double.
By doing what?
Changing it to a thing.
Changing it into its double angle identity. And of course, in the case of cosine, there's 3 of them.
1 minus sine squared.
1 minus 2 sine squared theta, right? And then we could, from there, kind of remanipulate things and try to solve the quadratic and all of that. But questions on that? All right. If you're finished with this 4th one, go ahead and find the inverse equations for these 2 regular algebra equations. Take just a moment to finish up this last trig equation, and then we'll look at these inverses. hard to pull out of the 4. I mean, you could pull it out of the 4 and get a 4/3, but that's annoying. This out of the way for you there. All right, let's take a look at this one here. Again, it starts out like all the others, right? Set it equal to 0, factor out the secant, set the factors to 0. You get secant is positive negative 0 over 1, cosine is positive negative square root of 3 over 2. When is secant 0? Never. Remember, the limited domain is from negative infinity to negative 1, and then 1 to infinity, but it can never go to 0, right? The hypotenuse can never be a 0 where the leg has some length. So no solution from that portion of it. But over here, positive negative square root of 3 over 2, all 4 30-degree angles. So we get 31, 52, 10, and 330 degrees. Questions on this? Coming over here, for finding inverse equations, remember, what's the key to an inverse equation, class?
Switch the x and the y.
Switch the x and the y. So we're going to x is equal to 2 over y plus 3. Remember, if what you're solving for is in a denominator, class, you're going to need to alternate to get it out. So if we kind of think of this x as x over 1, if we alternate, Chris, what are we going to get?
7 plus 3 equals 2 over x.
7 plus, you mean y plus 3?
Yeah, sorry.
Y plus 3 equals
2 over x.
2 over x. That offhand might help your brain process a little more clearly. And then to finish it,
You would just minus 3 away to get 2 over x minus 3.
there we go. So there's our inverse equation. By the way, if we wanted to graph the original function, where do we have an asymptote, class?
-3.
At -3. But, based on what we see from the inverse, where's our horizontal asymptote?
Positive 3.
2.
2.
0. X can't be 0, which means in the original, y could not equal a 0. So we'd end up with a parabolic, or hyperbolic function rather, looking something like that. Is that actually a function, class?
Yes.
Yeah. Is the inverse a function?
Yeah.
Yeah. Passes the vertical line test, so it's a function. Passes the horizontal line test, the inverse is a function. Looking over here, y equals x negative 5 quantity squared plus 1. First thing we've got to do, change x and y to get x equals y minus 5 squared plus 1. Then, to get the y by itself, subtract the 1, take the square root. Remember, our idea is we've got to put positive, negative, and then finally, plus 5. So a positive 5 plus or minus the square root of x minus 1 is equal to the y. By the way, if we were to graph this, we would get something like this for our parabola. Is that a function, class?
Yes.
Yeah. Passes the vertical line test, doesn't it? Is the inverse a function?
Yeah.
No, it fails the horizontal line test, right? The horizontal line crosses more than once. So this inverse is not a function, but this original equation is indeed a function. Questions on that?
Can you do a quick vertical line like that?
Yeah,
I
absolutely.
wasn't here that day, so
Yeah, so in the vertical line test, basically just imagine passing a vertical line. You're looking at this graph. If it ever crosses more than once, is it crossing more than one time, one thing at a time?
or is that?
No, I mean, it's continually crossing at one point, but it's never crossing at more than one point. So since the vertical line can pass over, this is indeed a function. The horizontal line test does the same thing for the inverse, but does it ever cross more than once? Yeah, it keeps crossing twice, doesn't it? So because it crosses more than once, even if you had something like this, here, is this a function?
Yes.
Yeah. Is the inverse a function? It is, except
Yes.
for right here. 1, 2, 3 different points, right? So right here, no, it's not a function. And it immediately looks like a function again, but there is that one little spot where it would cross more than once. So technically here, the inverse is not a function. Does that make sense now? All right, good. Any other questions on inverse equations, whether something's a function or not a function, those sorts of things? All right, let's go and practice with our inverse trig functions then, and their limited ranges and such. Of course, make sure we have those limited domains and ranges memorized for the test tomorrow. And remember, domain means what you can put in, range is what you get out. And really, the domains, remember, of your inverse functions are the old ranges. But if I had the arctangent of negative square root of 3 over 3, again, the only question you're really asking your class is when? When is tangent square root of 3 over 3? Thoughts?
1 over square root of 3.
Yeah, you got to recognize the rationalized form here. This is really just 1 over square root of 3. Okay, let's try that then. When is tangent 1 over square root of 3, class?
30.
All right, and the next question is, when is tangent?
Negative.
Negative, right? There's two things to concern yourself with. The SIGN and the ratio. Well, here the ratio says 30, but this says quadrants
2 and 4.
2 and 4. But you can't have both quadrants on an inverse function. That's the whole point of those limited ranges, right? Which of these quadrants is ruled out by the limitation on arctangent? Quadrant
4.
Ruled out? What's the limited range of arctangent?
90 and 90.
Negative 90 to 90. That is 4 and 1. It rules out quadrant 2. Maybe you misunderstood the question. It rules out quadrant 2. Quadrant 2 is no good. It's not between negative 90 and 90. So we're going to go with the quadrant 4, 4. Maybe that's what you were trying to say. What is the quadrant 4 form of 30?
330.
Normally 330, but again, that doesn't fall between negative 90 and 90.
Negative 30.
So go coterminal, and negative 30 degrees would be the solution there. I got a few more for you to work there at your seats. If we have the arc sine of negative square root of 2 over 2, the arc cosine of negative a half, and the arc secant of 2 square root of 3 over 3. Spend another minute or so to work on these, and we'll take a look at them together. All right, let's see how we did on these. Here, this square root of 2 over 2, class?
1
1 over square root
1 over square root of 2. And when is sine 1 over square root of 2? 45 degrees. When is sine negative? 3 and 4. But what's the limitation of arc sine? Negative 90 to 90. So we can rule out quadrant 3. So we're going to go with the quadrant 4 form, but again, not 315. Negative 45 degrees. How many had that for this one?
Why'd you go negative 45?
Well, quadrant 4 form is normally 315 degrees, right? But remember, we said negative 90 to 90. Well, that's way bigger than 90, right? So subtract the 360 to get negative 45. That fits within the range. Look at the next one. When's cosine of half? 60. When's cosine negative?
Quadrant
2 and 3. What's the limitation on arc cosine?
Bracket 0 to 180.
0 to 180. So that means we're going to go with quadrant 2, which is 120 degrees. How many had that for the third one? Excellent. Actually, it's the second one you did. And then over here, 2 squared 3 over 3?
2 over square root of 3.
2 over square root of 3. Okay, so when is arc secant 2 over the square root of 3?
30.
Yes, 30 degrees. And when is secant positive?
Quadrant 1 and 4.
But arc secant is limited to
Bracket 0 to 180 except bracket except 90.
same thing as this except 90. So therefore we can't use quadrant 4. We're going to have to go with quadrant 1 and just say
30 degrees.
30 degrees. How many had that for the last one? All right, questions on these? All right, now we're going to put it together with the regular functions. And again, inverse functions, class, your question is? When? It's what we were just doing, right? You're going to get angles, aren't you? But regular functions, rather, the question is what? And you're not going to get angles from a regular function. You're going to get a ratio of something to something, some value there. So I've got several of these for you. Y is equal to the cosine of the arc tangent of negative square root of 3. Y is equal to the arc sine of the secant of 5 over 6.
With arc tangent, you use the question when.
Inverse functions are when. Any questions on the first two? Let's just stop there because I know not all of you are finished. Any questions on the first two problems?
So why is it no solution?
Well, because sine can't be hypotenuse, or excuse me, opposite over hypotenuse 2 over square root of 3, right? The opposite can't be bigger than hypotenuse. This is smaller than -1, and arcsine has to start at -1 to 1, right? It can't fit in there. Right? Good question, good. Any other questions? All right, finish working on those last two. I'll put up a couple more here.
I'll take that.
All right, any questions on the second two that are already worked up there? Any questions on the second two? Going once on questions. All right, I'll go ahead and erase. Finish working on those last two. If you're already done, I've got some more problems for you that require your calculator. Let's find out answers to the nearest tenth of a degree. questions on the last two? Any questions on the last two problems? Before we get to the calculator stuff. How many got both answers on these last two also?
I just had negative 1 over 1.
That's fine. Yeah, negative 1 over 1 would be fine. No problem there. Any other questions on the last two? All right. Going to get your calculators out. Stay in degree mode for all of them this time. I believe, well, let me double check the test real quick. I'm fairly certain you only do degree mode on the test. Though one might wonder why we do so much grading in class. I don't know. Just degrees. So this way we'll be in degree mode for us, ready to go on in our next lesson. But staying in degree mode, let's write out the nearest tenth of a degree.
On mine, you do the arctangent, say whatever the number is, and then you do the inverse, or the.
Well, again, if you're going to use the reciprocal function, you have to use the reciprocal value also. So, for instance, if it says, for instance, the bottom one over on the first column says cosecant. Well, you don't have arc cosecant, so you have to go with the reciprocal function. So you're going to take the reciprocal function of the reciprocal value. Yes.
You mind going on number 4 so I can see if I have the light? Just make sure we do that.
Are we done with the first column yet? Everyone done with the first column? All right, I'm going to give you the answers here. Should have had negative 34.1 degrees for the first one. Should have had 33.9 degrees for the second. Should have had 54.8 degrees for the third. And should have had negative 9.9 degrees for the fourth. Are we good on the first column?
Yeah.
Working on the second column then. Did you work last night, Chris? Yeah. You seem really tired.
Yeah, I had to go in for trivia.
That one there is kind of weird, isn't it? Because you're going to have to use the arctangent, aren't you? Arctangent spits out values between negative 90 and 90. But you're not allowed to have a value between negative 90 and 90 for arccotangent, are you? You're going to have to do what? Add 180. Anytime you have arccotangent of a negative, take that negative angle it gives you. I think it gave you negative 53.1, blah, blah, blah. And you're going to have to change it 126.9 degrees.
It's a bad answer.
Yeah, unfortunate. All right. Questions on the second column? All right, that's pretty much the test. All right, so what we reviewed, pretty much what the test is going to look like tomorrow. And of course, your domains and ranges, make sure that you know those. The bulletin board will be covered. So, have them memorized. Last call for any questions. We've got about 2 more minutes. Any questions? Anything we went over today, you say, can we do another one like this one? I was
I'm ready.
I
confused.
think I'm ready.
Feel good about this one? Last test was a doozy. Here's a chance to make up for it. All right,
You
so
think this test could bring my grade back to a B?
depends on how well you do.
If I make an A, what about?
I don't know. I'd have to look at your grade to know for sure. All right. Well, no homework other than do whatever you have to do to be ready. If that means rewatching all or part of this video, do so, but be ready for the test in our next lesson. And the bell rings. You'll be dismissed. Have a wonderful rest of your day.